Okay.
Hi, good morning, everyone. Welcome to our event. Thank you so much for joining us today in this session. My name is Marta Lima. I work as Dissemination and Communication Manager at Ubiwhere. For those of you who can't stay with us till the end of the session, don't worry. We will make our webinar available afterwards on our YouTube channel and other social media pages for you to watch and rewatch as many times as you want. Our event, the City Nervous System 5G Enabled Verticals for Cities, will be divided into a total of 3 sessions, each one approaching one of the most relevant topics in this industry. Our first session is promoted by the national funding programs Compete 2020, PT 2020, and FEDER. In our first session, Dr. Rui Luís Aguiar will take us on a journey called 5G from Concept to Reality, giving us an opportunity to learn a bit more about the 5th generation networks and the challenges brought by its implementation. Dr. Rui Luís Aguiar holds a degree in Electronics and Telecommunications and a PhD in Electrotechnics. He is currently full professor at the University of Aveiro, holding responsibility for the Networks Department. Dr. Rui has vast academic experience. He has worked as adjunct professor at Carnegie Mellon University and has a guest researcher at the Federal University of Uberlândia. Furthermore, he has collaborated with the Adjunct Secretary of State in Communications, where he helped outlining the national policy on 5G. Dr. Rui also works as head of networks and multimedia at the Instituto de Telecomunicações. Well, that's an impressive resume, Dr. Rui. Thank you so much for being with us today. The floor is yours.
Okay, so thank you very much for this kind introduction. Good morning, or since this will be stored, well, I hope you are having a good day. Let me start by sharing my screen, because I know that I will have a very strict timing to fulfill. So I hope you are seeing my screen now with my presentation. This 10 minutes, sorry, this is not my physical presentation. Let me correct this, because I think this is a talk on 5G, right? So apologize for this, something that went bad. Okay, I've had some plans for this presentation. Meanwhile, I've been informed somewhat about the profile of the audience. So I thought it would be probably better trying to compress, 5G history in a couple of key messages for what I would expect non-experts to take at this time. Notice that I'm talking on March 21 from Portugal, in the middle of processes that are ongoing. So, main messages. What is 5G? Besides making a huge amount of news in the newspapers, well, 5G is the new generation of mobile communications. What does this mean? Well, first, 1G, we had mobile telephony. I actually carried an analog mobile phone, which was very much similar to a full backpack with 9 kilograms, okay? Really not portable. 2G was digital mobile technology. This made the telephones a digital thing which was transportable and a commodity. We still use 2G today. 3G was mobile internet. We brought mobility to that telephone, was the appearance of the smartphones. 4G, the generation which we are living today, is mobile broadband. At this moment, we use our smartphone as the basic tool. So what is 5G? Well, 5G is the network society. It's no longer broadband. We do expect all our communication needs, whatever they are, in whatever industry they are, to be mediated by this fantastic network. So, and this is a key point. Until 5G, the focus of the network was the user. From now on, is no longer the user, it's the economic ecosystem. So keep in mind, because, well, 5G is actually many dreams. These are just some of the dreams that were present when we were starting discussing 5G. This slide has maybe 8 years or something like that. And we are talking about something that connects huge amount of sensor networks, but is able to download a movie to your cell phone for you to watch while you are commuting in a minute when you are in any place. Is able to address the so-called tactile internet, my ability to teleoperate remote, robots, hands, or even cars. But it's also related to autonomous driving, which is not the same thing as a remote operation of a car. Okay. Then we are talking about something like you have your house fully connected every time at your fingertips. And you have things like the ability to take your cell phone, look at a nice building, and immediately you see a full spec, who was the architect, what's inside, what are the famous events that happened there, with things like virtual overlays or augmented reality. And I'm not even talking about things which are more expectable as video gaming. So these many dreams actually force 5G to be many things. And we typically look at 5G as having three major legs. Throughput, the ability to transmit faster and faster. Power and the number of devices, the ability to connect more and more devices. Latency and reliability, the ability to have short time, short delays on communications. So these three legs are actually important for different cases. So if we are talking about, let's say, sensor networks, typically we are talking about low throughput, but we are talking about millions of devices. If we are talking about, support of emergency services or about automotive driving, then we are talking about very low latency, and because it's and extreme reliability, because it's essential that the information suffers no problem. Okay, and then of course you have all the other examples that you can put, and depending on these examples, you can look at these three legs and see how important each one of these three legs is to that use case. So another message: there is not one 5G network. There is many 5G networks. They can be configured for different types of usage. And in fact, you can expect in the midterm for you actually seeing at the same time different networks providing different performances for different use cases. And notice that I use the word midterm. 5G is phased. You do not get all of it now. There is no such thing as a 5G. This is a process. It's ongoing and it will keep for many years. Actually, technically, we have this evolution, we call it releases, from a body called 3GPP. The first 5G release is the so-called release 15, which was created with something called non-standalone new radio. What does this mean? It means that you do have a new radio interface, but you are using the 4G network. So it's non-standalone. The 5G network will not be able to run without the 4G network. Now, release 16, which has already been standardized and is slowly starting to be rolled out, is already targeting something called standalone. This means that you don't need the 4G network to actually run it. Okay? So notice, like, if you look at this graphic where you see release 15, release 16, release 17, you see that they are ongoing. And all of this will be 5G, but the features and the abilities of the network will be very different. And in fact, then you also need to look at several details, like how long it takes from the moment that it's standardized until it reaches the market. And yes, if you see this, the release 15 is already about more than 2 years, but it's what you have on the market today. And the release 15 is the non-standalone. Okay, so this is what we are having now. So remember all my dreams that I was mentioning? I am not promising that you will get all of them now. When we talk about 5G now, what we are talking is essentially better 4G. And this means better internet access, more bit rate. It may mean slightly better IoT. And it's slightly better because since you have more bandwidth, you will be able to have better management of more sensors. But it's not particularly good for sensors. It's simply what we have today, slightly better with more speed. And you can also expect much worse geographical coverage because the rollout of 5G will be mainly targeting very dense regions at this moment. So if you are in a small town with a large of, countryside near you, you should not expect to have 5G as a key changer at this moment. It will change as well that, but will take still some time to reach there. So remember, 5G now is what we are going to hear a lot, but the 5G that many of you will need is the 5G tomorrow. What situation in Portugal, which is a good example? Now the first thing you need for a new network is spectrum. In Portugal, we have refarmed the digital terrestrial TV to allow some more bandwidth for 5G for the countryside. This has been done. At this moment, the auction for the frequencies is ongoing. In fact, I think it's ongoing for more than 1 month. At this stage, our 3 major commercial operators, mobile operators, they have already, all of them, done 5G trials. Some of them have already commercial procurement, meaning that they already know what they will start to install as soon as they can, as soon as this auction is finished. There is public information that a new operator is going to enter, has already gained the position to enter the Portuguese market. And there is something which I call the old new operator, because this is somebody which has a very different business model that exists for many years, has not yet reached traction in terms of impact on the market, but it will be able to compete in this new 5G market in Portugal. So this is what the status is in terms of the commercial rollout. Wait a couple of weeks and you will see actions on this. What have been done, and since this is a seminar in terms of innovation as well, there were many projects done both by academia, both by industry, mixed cooperations like I think you are going to hear. In particular, one key national project, the 5G Mobilizer project, Projeto Mobilizador 5G, which I helped create a couple of years ago and has been, I would say, successfully evolving towards its conclusion, leading to several types of products. And in fact, it's something very interesting because 5G is no longer only the communication, but is also all the other products that are being developed relying on the technology. Remember, 5G is about business to business, not only business to consumer. At this moment, in Portugal, we are seeing the startup of initiatives on the economic impact of 5G. The 5G that we are starting today is the 4G++. It's the business to consumer. The 5G that we are really needing is the business to business. It's the second phase of 5G. And we are talking about things like digital innovation hubs, trial platforms, and you are going to hear on this presentation some things about smart cities, some concepts in Portugal called innovation zones, and so on. So as an example, let me talk about something that we have and been launching recently, something called 5Gainer. And for the joke of it, it's 5G plus artificial intelligence, network, and reliability. So it brings all that. And this is an example of the things that we are doing now and pushing as innovation. And this is basically an infrastructure for supporting these business-to-business solutions, these vertical solutions over 5G. And of course, aims to reach those industries, provide education, training, and create a competence center for all this impact of 5G on the society. Now, the project is already being run. It's associated and running multiple use cases or starting to test multiple use cases that go from factory automation to train mobility to energy smart grid actions, some of them which are associated with this mobilizer project that you will hear in a moment. Now, to give an idea of how this actually works, it physically implies that we have 4 places in the town which are covered with 5G dedicated for testing. And just since my time is running, just to give an idea, this is the kind of infrastructure. And if you look at this graphic where you can see these pink boxes are actually commercial equipment which has been donated for this kind of trial and is being supported by, in terms of running it, by companies like Altis and with the cooperation of companies like Bosch and FSEC, and of course equipment is coming from Huawei, okay? And this is already for that second phase, the standalone 5G, the one for the business to business. And of course, we also have all the research and innovation tools that are required to make these things and to help this digital transition. As I said, this is just an example of things going in terms of innovation. I believe that during this webinar today, we are going to hear the outcomes of what were the innovation of 2 years ago and how they are now being ready to reach the market and move into this 5G network that will be rolled out in the very next months in Portugal. Thank you for your time. If you have any questions, I'll be open to them. I hope I didn't exceed too much my time.
No, it was just on time, Dr. Rui. Thank you very much for your presentation. I believe it was very enlightening for all, in that it gives us a much more clear perception on the importance and the impact of the 5G networks on our society. Thank you. Now I'm giving the floor to my colleague, Luis Conceição, from Ubiwhere, who will be sharing with us a bit about Ubiware's work on the national project Mobilizador 5G, also known as 5Go. Luis works as NFV researcher and developer at Ubiware in the area of future networks. Luis holds an MSc in computer Computational Sciences and a PhD in Information Sciences and Technologies by the University of Coimbra. He has worked as a research assistant at the University of Coimbra and as a backend developer at Red Zinc. He has also been an active participant in several national and international R&D projects, and author and co-author of several technical and scientific publications in his area of expertise. At Ubiwhere, Luis has been working as the lead developer of all NFV and SDN related projects, having been involved in different 5G PPP projects. Hi, Luis. Thank you for being with us.
Thank you very much. Good morning. Thank you for the introduction. So today, as Professor Rui Aguiar mentioned, I will be providing a quick overview of Ubiwhere's project in the realm of the 5G Go project, which is it's a key project in a national project in the 5G area. So first, the outline, we are going to overview the project's we're going to provide the project overview of 5G Go. Then we're going to view some Ubiwhere products, an outline of the Ubiwhere products. Then we're going to describe the architecture of these projects, namely the 5G monitoring system, the ANINET, the vulnerability assessment system, and also the intelligent surveillance system. Of course, these are products that Ubiwhere gained from an outcome from this project, from this national project. So the 5G Go is a very large project, a national project, with the intent of integrate a set of products provenient from different companies, like big players on the national market, target to provide to the 5G ecosystem. So it is divided in 4 main pillars. So the first one, it's called the product, process, and services, like PPS. The first PPS addresses the edge of the network. It provides 5G spectrum analysis, CPE virtualization, 5G radio monitoring, and so on. The PPS2 addresses the core of the network, which pertains the policy, orchestration, assurance, support, and security frameworks related to the telco operator's core. The PPS3 addresses the machine-to-machine communication. It's targeted to vertical markets, namely the different use cases of these vertical markets, and provide some products related to security, video streams, and also the MEC. The PPS4 it's also directed to the vertical market, but addresses more a human communication and interaction. So Ubiwhere is present in PPS 1, 2, and 3. So we don't participate in the PPS 4. However, we also integrate our products with in this ecosystem of the 5G Go project. So some of the Ubiware's products, the main products that we have time to present here, pertain to the 5G monitoring system, which is a platform that monitors radio quality from any geographical location by retrieving and processing data from measuring probes on a specific territory. The ANINET, which is part of the core security framework of the 5G Go ecosystem. The vulnerability assessment system, which also is part of the security framework, and a vertical, which is the intelligent video surveillance system, which is targeted to prevent hazards on railroad level crossings based on autonomous computer vision monitoring. Okay. Seeing in detail the 5G monitoring system, the main objectives here with this system is, let's say we have Portugal, a geographical location. We want to monitor some locations around a map, and we deploy several probes, and we have the towers that provide 5G radio access, and we want to gather the information that the probes are providing into a 5G monitoring system core, and then provide that process that information from hundreds in the hundreds of probes, and provide that information in the single dashboard, in a single web portal, and also provide some information to external entities like statistics and etc. So this project, it's a very complex because it has to scale. Okay, it has to support a lot of probes, and here we present a high-level monitoring of the 5G monitoring system core. So the first one is the probes have to register in the manager. We have to provide a probe register database. The probes then send data, raw data, to a broker, which can be scalable. Just for we decided to divide this in microservices because the system has to scale, and this may be replicated. The manager, the broker, and the command, all these models can be scaled up, and hence the microservice approach. So the probes send data to MQTT broker. The consumer gets the data and stores the data in the raw database. So and of course we have to also process the data to be user friendly, to finally provide the dashboard, the users, the operators with the processed and filtered data. Of course, in the dashboard also sends can also send commands to the probes, like start, configure probes, and install probes, and etc. This is also done, we also have an alarm system, which is a key element of this architecture, which allows to define by the dashboard. Let's say, for instance, that a user wants to see if in a certain amount of time, if the quality of that single probe reaches below, doesn't reach a certain amount of quality, a certain amount of decibels in signaling. So the alarm is triggered, the alarm is configured, and then triggered, and an alarm is transmitted to the dashboard available to the users. So, and as I said, to external entities, well, you also provide statistics about this information. So this is a brief high-level architecture of the monitoring system. Then we have Aninet, which has which is part of the core system network. The objective is to prevent attacks by detecting a normal activity around entry points of the network, of the telco operator network, to mitigate the impact of the 5G network services that have been compromised, monitor record attackers' methodologies, so we can see what is going on, what the attacker is doing inside the service, and aggregate and report threats to operators' dashboard, to a central system. So we have the network, the Aninet agents that have to expose the ports to well-known services, and they are meant to attract exploits by exposing well-known ports, let's say to attract attackers to hack the agents. So on the other hand, we have the Aninet server that that supports the connection to all the Aninet agents, to all the deployed agents, and they are responsible to instantiate impromptu containers that provide real machines to ludibriate the attackers. They forward communications to external servers. They monitor and record attackers' activities. And of course, they report the aggregated activities to operators' dashboard and also notify the 5G core services about the service instance breaches. So we have here an overall architecture overview. So the attacker agents are deployed somewhere, can be inside a network service or around the telco operator network. And we have a register that establishes a secure tunnel between the listener of the agent and the forwarder of inside the network service. And let's say that the attacker reaches this listener and connects, for instance, to an SSH exposed port, and it is forwarded then to, let's assume, an XH proxy, which is a container is provided with an SSH server machine. So the attacker will think that is inside an SSH server or inside a server by using SSH, and we intercept all the activity, all the commands that the attacker does, and record this, process this information, and also provide it in the dashboard, all the activity that is being done. At the same time, the 5G Go core control services like the HL policy assurance and orchestration are informed about this, and they are informed about this, and they may consider that the service, the network service, is compromised and decide to, for instance, stop the network service instance because it has been breached. So it also dispatches information to 5G security events collector, which is another dashboard for the security framework of the 5G Go project. So here we have an example, a typical NFV network service. We have several VNFs with an ingress point, right? An egress connection point. We have several VNFs, and let's suppose, and then typically we have a management connection point as well to the orchestrator be able to configure the VNFs, which is an E3 type of link, which has access to all the VNFs in the network. Once the network service is instantiated, it also instantiates an Aninet agent inside that network service to monitoring that service. So the agent is connected to the Aninet server, which is running on another slice, an external slice. And let's suppose that the attacker gains access to a VNF somehow and starts attacking that VNF. And a typical behavior of the attacker is to do a lateral movement, which is to exploit, to exploit other machines that are within that network. So they start to scan for open ports, for well-known services around that network. And Aninet agent is, of course, it's like a honeypot, right? So it has several exposed for well-known service ports, and the attacker enters that Aninet agent and establishes the link to a well-known service. And the AnyNet service automatically provides like a server or container, and for all the attacker's activity, and for all the server. And like I said previously, at the same time, the notification that the service instance, the network service instance is compromised is done to the 5G core services, which may take the decision to take the network service down and stop it because it has been compromised. So the vulnerability assessment system is also a core security, part of the core security framework of the 5G Go. In this case, it has the objective of scan for network vulnerabilities within network services. So it is also placed in an agent like a slave in this case is placed inside a network service, and the obtained results of that scan to the machines, to the VNFs, well, to the VDUs of the VNFs in this case, right, are sent to the VAS master. So the VAS master is based on OpenVAS. It collects all the results from the slaves, and it is configurable, which are the network vulnerability tests. The levels of vulnerabilities are configurable, which are the boundaries that we allow to reach. And of course, it notifies service instability, which are above thresholds to the 5G core, 5G Go core services, and the 5G Go security events collector, and also to the dashboard. So here we have an high-level architecture of the VAS, which is very similar to the HoneyNet. We'll have agents. We register the slaves on the slave manager in the VAS master, and then we have scanners on the slaves that scan vulnerabilities in the VNFs of a certain network service. So the results are collected and recorded and made available by an API to the dashboard. So, and also the results analyzer scan if the results are above certain thresholds, and also notify the 5G Go core services and the 5G security events collector, which may take action if necessary. So passing through a vertical now, the intelligent video surveillance system. It's driven to autonomously detect and classify objects in railroad level crossings to prevent hazards. So it classifies and detects objects when the train is passing, when the level is closed. It is meant to be completely automatic. So it broadcasts real-time video of level crossings to the control center, which is running on the core. And it provides a global alert system capable, the core provides a global alert system capable of contacting emergency authorities. So we also here leverage edge resources, which the small cell is able to transmit video streams and events via 5G radio to nearby equipments, to railroad operators, and also to the train conductor. So the real-time video processing and classification is also done on the edge of the network, taking the compute resources that are available at the edge, like built in the small cell or urban furniture, and then after processing this information, it sends events back to the core. So here we have a more detailed architecture about this IVS system. Let's, for instance, assume that we have two cameras in a railroad level crossing, and we have a streamer node. Okay, this is the network edge, this part, and this part is the network core. So, and then we have a streamer node that is listening. It's gathering the streams of videos, and detects, this model also detects if there is movement on the railroad level crossing. If there's movement, it passes the stream to the classifier node, which classifies the objects in the stream. And if relevant objects are detected, like that can provide hazards, such as persons, cars, or some big rocks or something like that, it is prone to have an accident. So it generates events, emergency events, to the MQTT, and it is passed through an MQTT broker, which is then consumed by an edge router, which passes along the information to the core unit, to the central unit. So the event is processed and made available to the dashboard through instant notifications. Okay. So on the other hand, the dashboard, the operator on the dashboard, also has the power to view streams from arbitrary regions, from railroad crossings that has at his disposal. So well, and also when I forgot to mention that when the event is triggered, it automatically starts the event to be able to see what happened since the beginning of the triggering of the event. So this part is extremely important, because it may trigger an event in the beginning, and when the operator sees the real-time video feed, it may not be present, no longer be present the hazard in the railroad crossing. So it has to see the historic video that triggered that event. So at the same time, when these events are triggered, these emergency events are triggered, the railroad operators, which are in the premises of the railroad crossings, receive event notifications and also consume video streams of what is going on the railroad level crossing, and the train conductor also receives events about what's going on the next railroad crossing that you will pass on. Initially, the train conductor was supposed to receive the video, but for legal reasons, the FASEC did not agree with the train be distracted to seeing the real-time video stream. So it only receives, for now, the event notification about some hazards in the upcoming railroad crossing. So basically, this was a quick demonstration about some of the projects that Ubiwhere has contributed in the project, and thank you for your attention. If there's any questions, please write it in the comments below, and I'll try to address them.
Luis, for such a sound presentation. It's very interesting to see the solutions and services already in motion to make sure we seize the full potential of this new technology. I do have a question for Dr. Hui. Dr. Hui, you gave us a very interesting perspective on the gap between the present and future of 5G. You mentioned that 5G is an ongoing process that will take time, while also giving us a brief view of the current status of this network in our country. So my question is, how can Portugal aspire to be at the forefront, of the implementation of 5G?
Well, not sure if you are talking about implementation or rollout, which are slightly different things. If by implementation mean product development, well, I think 5Go is probably a good example, right? 5G will, in the end, will aggregate a huge amount of solutions, both for vertical businesses and for the telecom industry. And I think we are still out in many places on what those solutions will be. And most probably many of them will be custom built for specific markets and specific niches, positioning of different companies and of different types of products. So I think there is still time for us to actually leverage on the industries and what we know how to do well, and simply push forward in terms of taking those products into a digital transition phase and relying on 5G and taking opportunities on what the 5G technology will bring, and that will lead to changes and increase potentialities associated with those products. So this is one direction, which is what can we as a country develop for the 5G global market. If by your question you meant rollout in the sense of, having 5G running, I mean, that's out of the question at this moment. Okay. 5G is a reality in many countries in Europe. There are more 5G customers in Korea than population in Portugal at this moment. Not even telling you what China is doing in terms of 5G. So in terms of rollout, we have not yet started to officially roll out, so we are outdated. On the other hand, current rollout is of this 4G++, having a better internet. I can tell as a sort of a joke that on this infrastructure that I mentioned on 5Gainer, which I actually, one of the rollout places is in the research institute, Instituto de Telecomunicações. I already have there, bit rates of 1.2 gigabits per second. And it was limited on the abilities of my physical equipment. I think I can probably get 1.5 to 1.7, but my machines don't get more than 1.2. So that's it. So on the other hand, you say, why do I need 1.2 gigabits per second? Well, it's nice to say this, but do I really need 1.2 gigabits per second? I mean, it's just simply faster internet, okay? So if we are late in this faster internet 5G, the one that's starting, we still are on time to actually push as a nation towards the second stage of 5G, which is this business-to-business view, the 5G for the machines, the 5G for the reliable services. And there is really no serious rollout anywhere in the world. And if Portugal moves fast on that direction, maybe we can lead, and we can even help our economy to recover towards what will be the future generations of industries in the world, which will have to rely on this digital technologies, this connected society, this network society.
Okay, thank you very much. That was very interesting. We will now proceed to our second session, the Neutral Hosting Challenge. This session is promoted by the national funding programs Compete 2020, PT 2020, and FEDER. In this second session, with the help of Paulo Valente and Pedro Diogo, we will explore the concept of neutral hosting and how can this new approach represent an opportunity for 5G implementation in urban areas. Paulo Valente, the first speaker of this session, manages Tech for Policy, a consulting business in Brussels focused on technology policy and regulation. He owns a particular expertise in telecommunications, media, and the postal sector. He has more than 20 years of experience advising leaders in these sectors on strategy, policies, regulatory, and spectrum issues. During the recent years, Paulo has also followed the digitalization of various industries, namely the adoption of connectivity in new business models. Paulo has held various senior roles in telecommunication operators, standardization bodies, regulators, and trade associations. Paulo, thank you so much for accepting our invitation and being here today. The floor is yours.
Thank you, Marta. Good morning to everyone. Thank you for the invitation. It's a really good, very good, big pleasure to be together with you to talk about this very interesting topic. I think neutral hosting is one of the key enablers of 5G. The fact that 5G is coming in our direction, as we have just discussed before, it is very important that we will have a very quick and robust network to enable all the services that will be possible. And so I will focus with this particular element of the 5G rollout, which is the neutral hosting. So I will cover what is the neutral host infrastructure and why is it crucial for the 5G deployment. Why are cities so well positioned to enable this process, this model? And why can cities benefit with the neutral hosting opportunity? So first, let's start by looking at what is the neutral host infrastructure. As you probably remember, when operators started to operate many years ago, the first mobile operators had their own infrastructure. One of the characteristics that led to the name mobile network operator, the MNO, was exactly that they owned their own infrastructure and they deploy their own services. And this corresponded to a single user and ownership. So each one had their own investment, and the networks, the services were distinguished by the quality of each network. But as long as technology evolved, what we saw was that the several elements of the network were no longer an element of distinction. So operators, because they wanted to be more efficient and use their resources where it would be more useful, they started to share certain elements of the network and kept on having their own services completely independent. And that's where we reach the neutral host, which is a different model. It's a model that believes that there are some elements that can be provided independently for any mobile operator, and this infrastructure is not run by the operators, but it's run by a neutral host player. It's a third-party entity that will provide this possibility. This has already been in place in several venues, like, for example, football stadiums, which are by nature large public venues, shopping centers where you have distributed access solutions. And this is how a place where doesn't accommodate a lot of infrastructure and this needs to be rational, proposes a solution that allows all competitors, all operators to be present, but with the most efficient solution. There are several advantages that we can immediately raise when we look at a neutral infrastructure. It's the reduction of operating costs, because it's only one network that is going to be operated, although it can be used by all operators. It's the reduction of the deployment costs, because the civil construction is by far one of the largest portion of the deployment costs, and it's a very big weight. It has a very big weight in the operator's balance sheet, and also the rationalization of the public use of the public space use. That is something that is also important. We cannot have the public space used with 3 antennas that are simply sharing the same space. It doesn't make any. It is not rational to do it like that. So Glenn, the second question is, why is it crucial for 5G deployment? As we have just listened, we are evolving to a new model of mobile services. These mobile services will be mostly based on a business-to-business relation, on a business-to-government relation, and this will have a particular requirement. As you can see on this slide, I wanted to highlight this importance. 5G will work mostly, or at least the frequencies that are regularly described as 5G frequencies are the 700 megahertz, the 3.6 megahertz, and it will be the 26 gigahertz that will be also made available very soon. The auction that is taking place today in Portugal is focusing on the 700 and the 3.6, beside other frequencies that were also available. And one particular important aspect of these frequencies is that the higher frequencies have one characteristic. They deliver more capacity, but they have a shorter range. The lower frequency has a longer range, but has less capacity. So this conundrum has to be solved by creating small cells. And that's what 5G will be. Will be about populating urban areas, mostly, with multiple small cells that have low power, but they have a short range. And this short range means that we will have to replicate in multiple sites these small cells. This poses a big challenge. This poses a challenge because the space is not perhaps enough, or at least it will create a big challenge to find all the spots required to do it. And on top of that, 5G is focused on improving the way that the services are experienced. These are things that are coming in the releases that were mentioned before. The enhanced mobile broadband, which will be more capacity that will be, and more speed that will be available. The ultra reliable for time sensitive communications, and the massive IoT that we all are very eager to and anxious to have available to deliver all the IoT services of the future. So to deliver these new capacities, operators will have to use the desired frequencies, but which in turn will have a lower coverage. So to solve this, they will have to put more small cells, which will require more devices per area covered. So this then we have another question: why are cities so well positioned to enable neutral hosting? First of all, there are many, or at least there are several possibilities of neutral hosting. Neutral hosting managed by the operator that installs its own solution and allows other players to come and play and use their own infrastructure, but also the venue owner to deploy their own neutral hosting solution, or even cities that are deploying their own infrastructure, avoiding an overcrowding situation that many operators, and we know that, for example, in Portugal, we have 3 mobile operators at this moment, but we will have mostly certainly a new one that will come, and we have another operator that is also present on this area. And this is how the cities will have a key role to play on this. First of all, because one way or the other, they are evolving to a smart city. They are bringing new services based on telecommunication technologies, and the city officials are the ones that know well how their space is organized. So having that in mind, they are the ones that can in a very efficient way do all the planning and that is required to deploy the small cells. So finally, why can cities benefit from this neutral hosting opportunity? First of all, because if it's a city-driven neutral infrastructure, it can leverage the knowledge that they have of the territory and the development plans that they have to provide connectivity for citizens and for business. Furthermore, the fact that a city as an initiative to have a neutral hosting infrastructure, it can maximize the investment because they have other ideas in mind. They can use it to deliver to change and to improve the public lighting, to provide charging points for electrical vehicles, for Wi-Fi spots, and many other sensors that are possible to use on that. But there is one caveat that we need to keep in mind. According to the regulation that exists today, operators can deploy small cells without any licensing process, which can create a massive impact on the urban planning of the city. So how can a city promote a neutral hosting infrastructure? By anticipating, by proposing, by being proactive, and developing a technical partnership with operators, with the technical experts that can negotiate with them, together with them, and drive the mobile operators' small cell deployment. This is a question of proposing solutions for the operators. They are very eager on doing this, and the quicker the operators feel that there is an opportunity, the more they will jump on it. So there are several business solutions that are extremely attractive for operators and for cities together, and this will mostly avoid the unplanned small cells deployment. So just a final phrase that I think it can be very interesting for all of us. The best way to predict the future is to create it. I think cities have a very important opportunity in their hands, and the quicker and the better advised they can to look at it, I think that there will be a very promising situation. So thank you very much, and that will be all. Thank you.
Thank you, Paulo, for such a comprehensive introduction to this new concept. It was very enlightening. The second speaker of our second session is my colleague Pedro Diogo, Telecom R&D Manager at Ubiwhere. Pedro Diogo holds a master degree in telecommunications and informatics from the University of Minho. Since his graduation, Pedro has co-founded a health and fitness startup, working also with a different startup as technical leader. At Ubiwhere, Pedro has been working as a project manager and smart lamppost product manager, while also researching novel technologies such as V2X, DLTs, and smart contracts. Currently, Pedro Diogo has been managing different R&D projects in the area of DLTs and telecom. Pedro will be sharing with us the national and international projects that have shaped Ubiware's vision on the neutral hosting approach, namely the national funded project UrbSense, and how this new concept can help building smarter, more resilient, and citizen-centric cities. Thank you, Pedro, for joining us today.
Thank you, Marta. Thank you all for joining. I'm going to share my screen now. Okay, let me know, Marta, if everything is all right on your side.
I'm not seeing your screen yet. Okay.
Should be on now then.
Yes.
Correct? All right. Yeah. Okay, so hi everyone. Yes, so we had a very good presentation from Paulo a few minutes ago. That is a nice overview of what neutral hosting actually is and how cities can embrace it. So today my presentation will be focused on what Ubiwhere has been working on this particular topic, the challenges that we have come across, the products that we are building, and the sort of innovation we are doing in the different research projects. So starting with the neutral hosting and not going that deeply into this particular topic, because Paulo has already mentioned quite a few reasons why we need it and why it's a relevant one. So yes, so we do know that right now we have different networks. We have different networks with different requirements, such as throughput, latency, packet loss, capacity. Some of these networks or services deployed in an urban environment, they may be working in a private manner or in public networks. Furthermore, we have more users and more bandwidth coming. I mean, we need more bandwidth. However, spectral efficiency is already close to the Shannon limit, so we can't really you put more bits per second in spectrum without going to much noise or errors. We have new strategies to tackle this, like spatial multiplexing, MIMO, but most importantly, and this should be the focus of this discussion, is the densification, meaning the installation of new smaller cells. So going from bigger cells like the tower cells to smaller ones closer to the user for added capacity, as mentioned also by Paulo. So we've started to do so in an urban environment. One way is to move to street level, as mentioned, and deploy the smarter and connected infrastructure, which can enable this massive and more dense deployment of these smaller cells. We've been working on a solution called Smart Lampposts, which not only allows us to deploy these smaller cells and edge computing elements inside the lampposts, but it also tackles other requirements like EV charging and any other IoT solution. So a neutral host owning this infrastructure, such as cities, they can capitalize on this investment, allowing them to tap into the telecom ecosystem and start acting somewhat as smaller tower cos, like owning new cell towers. So to this end, we've joined this joint venture together with Inteligalva and ProF, two different Portuguese companies, and we've launched an open platform and web marketplace connecting these exact infrastructure owners and the different tenants who hope to exploit this particular infrastructure. So with this platform, site offerings are listed, which are to be explored by the different parties according to the site owner's pricing model. This removes the barrier for site surveying, the licensing and installation of new infrastructure and equipment, while also reducing OpEx. That was our focus. However, when thinking of this platform, we're mostly allowing neutral hosts to do site or mast sharing. Also mentioned this before by Paulo. However, in order to scale horizontally, sharing can't happen only at this infrastructure level. We need to go into the RAN and the core mobile networks. So the neutral host can thus further squeeze its investment on not just the passive infrastructure, but also the active equipment to add more capacity. And this means sharing or adding more capacity to the actual smaller cells, like the equipment that I just mentioned before, which can go inside the different lampposts. So we may have we may have more than one small cell inside the lamppost, but you can also have more tenants inside each small cell, let's say. So we've started experimenting with this model and the new paradigm in a H2020 research project called 5G City. This was in 2017. The focus of this project was exactly to showcase how cities can embrace this neutral hosting model. We've deployed it in different use cases in 3 different cities: Barcelona, Bristol, and Lucca, all of them playing this role of neutral host. And the different equipment that was installed citywide allowed other service providers on top to request this neutral host for a particular network slice, upon which their services could then be deployed while having access to a dedicated 5G network slice. So in this scenario, the neutral host was enabling not only a site and a RAN sharing environment, but also allowing different tenants to get a chunk of an edge cloud. That is a subset of these computational resources. And this last part is important as we're now getting into the edge computing, which I will go into more details in a couple of minutes. So one of the use cases, that we have on this project was ours, which was related to V2X, or vehicle to everything. In this case, the slice that we needed was more oriented to a URL LLC, which stands for ultra reliable and low latency sort of network. These shots were actually taken in the city of Barcelona, and you can see here, for instance, some equipment already installed in also in some of the lampposts that we've had installed citywide. So we've managed to track and evaluate the performance of these networks and the resiliency of the deployed services on this particular slice. And now we're moving towards this city nervous system, an initiative that we are working at Ubiwhere to realize this vision of a well-connected digital nervous system. This is coordinating everything from infrastructure, like the smart lamppost mentioned before, to edge cloud and the radio connectivity platform. So one of the projects that we have internally to realize this vision, or to start realizing this vision, is called UrbSense, also mentioned before by Marta, where we are testing different technologies to combine a unified solution for cities to manage their IoT devices and data, edge computing to process this data, and the particular neutral hosting paradigm. So full demonstrations have been taking place in Helsinki, Aveiro, and very soon in Barcelona as well. The focus of this project is thus to facilitate experimentation, providing user-friendly platforms for service providers to test different applications, benchmark new use cases, and for the neutral host to evaluate the particular business opportunity that may come from this particular neutral hosting paradigm. However, this is not just connectivity. I did mention edge computing before. So to get into the quality of service and experience promised by 5G, there's a need to offload some of the computation closer to the end user of this user equipment. In an urban environment, for instance, this may result in distributing the load across a myriad of smaller and low energy compute resources, which are widely distributed in the city. One prime example is the use of, for instance, video graphics or video accelerators to, for instance, aid with use cases or scenarios where we may need either 4K streaming or augmented reality sort of use cases. So this is particularly important for the ultra reliable and low latency sort of communications I've mentioned before in the vehicular communications scenarios, but also the eMBB side of things, where we need bandwidth and throughput to encompass these particular scenarios that I just mentioned on the media side of things. Okay, so how can we do this, and what actually the role of the neutral host in all of this? And well, answering the second question already, then this is particularly important for the neutral host because, as mentioned, everything now is, so we have a new architecture coming from it's a NETSI standard. Let's say it's MEC, stands for multi-access edge computing. There's 3GPP support, like Dr. Hui has already mentioned. 3GPP is a body that standardizes all of these mobile networks. So there is support for this facilitated MEC. And that means that the new architecture coming from 5G and the innovation that we've seen will allow us to more flexibly and in a more dynamic manner to orchestrate all of these services, making sure that the particular data, for instance, coming from the users will be or may be pre-processed closer to the edge or closer to the particular end user. And you can do so using standard interfaces to manage all of these and to tap into the user plane. So going back to the initial slide depicting the different use cases and network requirements, this combination of network slicing, MEC, and the new 5G service-based architecture is what will enable this agility, as mentioned. So the diagram here is depicting, for instance, the placement of the user plane function, which is a new function coming from the new 5G service-based architecture. We can orchestrate this particular service closer to the end user. And for instance, you can see the edge cloud being a prime example to host this particular UPF, the user plane function, so we can get access to the data closer to the user, and thus enabling more low latency sort of applications and scenarios, since we don't have to go all the way back to the core and have more higher latency, which is not ideal for this particular scenarios. So this is also standard, like this is the network slicing is being standardized in 3GPP, of course. We can have what we call the different PDU sessions, separate this user plane function and the data networks per particular slice requested, and even multiple user equipments can be on multiple slices depending on the application. So all of this is not really easy for the neutral host to manage, and this is going too technical, but the key message here is this is not high, so the opportunity for neutral hosts is there, of course, but 5G and the new use cases with edge cloud technology is not particularly easy to manage and to tap into. Then comes another question regarding the interoperability. So we do have different environments. We don't have just one vendor, right, creating these access networks or providing the particular small cells. So we have different vendors. Not all of them respect or are aligned with the 3GPP APIs, and that's where the ORAN comes into place. So ORAN is not, it's also splitting like we are doing on 5G, but basically ORAN is adopting cloud native solutions as well. Basically a way to orchestrate all of these services using cloud native technology. It's happening not only at the core, but also in the RAN with ORAN. And as mentioned, it is allowing this multi-vendor intelligent cloud RAN ecosystem. It's moving the network intelligence to the edge, and it's an attempt to make 3GPP APIs truly open. That means that from a higher level, from a business perspective, let's say the neutral host can ensure that its own service that it's offering will work regardless of the underlying vendor that is providing the particular small cells, let's say, or the network equipment. Furthermore, we do have access to a more intelligent layer, which we can extrapolate particular data, which is required to more intelligently and dynamically manage all of the services and networks in an automated way. So where is it leading us after all of this? So we're coming to a fully fledged 5G as a service. There's a lot of new technology coming into place, but what we want really is to democratize 5G networks. As mentioned before, this was not a monopoly, but an ecosystem where one party, like the MNOs, they had the full power and they were the only ones providing these sort of 5G networks. But now, with the softwareization and the new standards, it's easier to have new players like the neutral hosts to tap into this ecosystem and so it's a business opportunity for these particular entities. So what we are working now is on a multi-tenant 5G and edge cloud platform. We are combining all of this technology and to allow for multiple possible business models and revenue streams for neutral hosts. We're going from site sharing, as mentioned before, with the Smart Lamppost platform, to RAN and edge cloud sharing as well. It's 100% cloud native, and we're using virtualization and orchestration technology, so it runs on any hardware we may have. There's no vendor lock-in thanks to ORAN. So, and on top of this, we are working on the building and the settlement layer on top of open blockchains to do things, of course, like financial transactions, but also service level agreements, negotiation, and monitoring. Make sure that the particular requested network and services will comply to the agreements that have been previously agreed upon by the different parties, right? So that's how the DLTs or the blockchain comes into place. However, all of this sounds pretty easy to do, or okay, so not easy, but doable, let's say. However, there's some sort of elephant in the room, which is the spectrum, and it is indeed difficult to manage this. So basically, to have a 5G network, we need spectrum, licensed spectrum. It gets complicated when it comes to the non-public networks, because we may have the standalone private network, non-public networks, commonly referred to as private 5G or 4G networks. We have networks that we may have non-public networks, but which are provided by a public PLMN. And that's exactly what happens when we're doing run sharing scenarios with the MORAN and MOCN. And however, there are new legislation coming into place which is particularly of interest to the neutral host, and those are, for instance, the possibility to have access to subleased spectrum, and that is spectrum that may be subleased by a public PLMN to a private CSP or a neutral host. Essentially, what that means is the MNO, which already has access to spectrum, they can sublease to, for instance, a city for a particular period of time, and also for a particular location. We have also the shared model, like the CBRS that we see in the US, where multiple MNOs may have access to the same frequency, or even the unlicensed, if we intend to go that route, like technologies such as the LTU, Multifier being a prime example, or the licensed assistant, the LAA, for extra bandwidth, where we may have non-3GPP radio access technology such as Wi-Fi being working closely together with 5G or licensed spectrum as well. However, we're thinking that taking all of the regulation aside and all of these hurdles, which may be a bottleneck, we are thinking of, well, maybe we can provide access to this particular spectrum if we can tokenize it, let's say. It may be an asset. So if we're working on a marketplace and open platforms, if there's a way to share this particular or to resell this particular asset in a way that is compliant with the current legislation and it's authorized by the, for instance, spectrum regulators and authorities, then maybe we can have this fully fledged end-to-end 5G as a service platform, because we may request access to sites, small cells, the computational resources which we need to deploy the different services. And then we may also have access to the particular spectrum, which may be provided by, again, by an entity like a MNO, which is, well, it's okay so this MNO may be okay with this option of reselling a particular chunk of the spectrum for a brief period of time and for a particular location. So that may be something that we can do, and that's exactly what we're trying to do in another 5G related H2020 project called 5G Zorro. We do have a partner that is indeed a spectrum authority or regulator, that is the Malta Communications Authority. And one of the use cases on this particular project is precisely the dynamic spectrum trading. We are using DLTs for business agility, to enforce trust, and the SLA establishment, and making sure that the SLAs are being met. So this is ongoing research. There's a lot of zero-touch security and trust built into the project, where we are automating the whole networks and service management. And to wrap up and moving forward, and to just close the loop, I know I'm possibly over time, 30 seconds over time, so 1 minute more and I'll be finished. Right now, we are working this vision of 5G as a service that we mentioned. We are actually building it, and in the scope of another project called the 5G as a service. So this is an FTI, which it stands for Fast Track to Innovation, and the focus here is not to do, well, it's not so much on the research side of things, but rather to focus on the business and the sort of use cases and scenarios, and to come up with a product that has a clear market fit, and which has been already validated by the most relevant stakeholders, like the regulators, MNOs. So yeah, it's a natural evolution to the existing smart lamppost platform, because we are coming from a site-based marketplace to a fully fledged non-public networks or private 5G networks with built-in MEC support, billing, and settlement powered by a DLT. Again, this is a project that we are working with other partners at the moment. But this is the overarching goal that we have here. It's the culmination of all research thus far into this new product. And spectrum is also being tackled here. Yeah, that wraps up everything. Thank you for your attention. If you have any questions, I'm of course free to answer those.
Thank you, Pedro, for sharing such a complete piece of Ubiwhere's approach on this innovative concept. It's very interesting to see by Pedro and Paulo's input how this neutral hosting approach unlocks such a wide set of opportunities for cities, positioning them with relevance in the 5G market, and that some European cities are already making use of this technology. This brings me to a question I would like to ask Paulo. Paulo, you've shown us some of the good practices inherent to this new technology for cities to make the best use of it. So I would like to ask you, which are the European cities or countries that you look upon as key models of neutral hosting good practices?
Marta, that is a very important question. The examples that I showed were based on an investigation that I did on cities that are already doing that. I think Helsinki is already doing a very good job. They have done a lot of studies to understand how this city-enabled neutral hosting model can work very well. So I think they are doing a very good job of understanding the pros and cons of doing this. But mostly what I think it's important for the city is to understand that they don't require the technology knowledge. What they need is to be supported by the right enablers of this knowledge. What Pedro described is critical. Nobody in a city needs to understand this. What they need is to be supported on this knowledge, and then make their own decisions to have a good planning of deploying the network. I think it's the key element that we should see as a best practice, in my opinion.
Okay. Thank you very much for answering my question. Last but not least, we're wrapping up this event with its third session, Smart Event Processing Enabling City Operations. This session is endorsed by the national funding programs Centro 2020, PT 2020, and FEDER. Ricardo Vitorino, Smart Cities R&I Manager at Ubiwhere, will present us with Smart Event Processing, a disruptive tool that allows smart cities to be alerted of emergency situations and have the capability of smart, fast, and coordinated response to these particular moments. Ricardo holds a Master in Computer Science from the University of Coimbra, having started working in 2011 in the Smart Cities and Mobility area, where he helped create an open data platform for urban mobility. Since then, Ricardo has worked on diverse projects related to the smart cities context. He joined Ubiwhere in early 2015 to work on its smart city solutions, mainly the backend services regarding mobility. Ricardo is currently responsible for the technical team working on smart city software solutions. Ricardo, thank you for being with us.
Thank you, Marta. Hi, everyone. So I'll try to share my screen. I have a brief presentation that I kindly ask you to validate that you're now seeing the slides.
Yes.
Okay, good. Let me just move this over here so that you don't see a black box. So thank you again for the opportunity. I'm afraid I'm not as an expert as the previous speakers, and I hope that you have been able to learn a lot as I have in the previous slides. Here I'll be, as Marta said before, I'll be presenting a specific product or use case that we have developed within a project. And as you might know, the European Commission and concretely the European Civil Protection and Humanitarian Aid Operations, in recent years we have seen a wide range of adverse events that caused the devastation of human life, property, the environment, and cultural heritage. So these disasters have triggered by natural hazards alone have cost the EU more than 90,000 lives, unfortunately, and more than 500 billion of economic losses between 1980 and 2017. These are the most recent metrics that we can assess in the European Commission. And since the disaster risk is dynamic and evolving, it requires systematic monitoring in order to be able to adapt the risk management policies to the changing situation. So the European Commission has published the overview of natural and man-made disaster risks the European Union may face in several editions, and the most recent one, the one from 2020, presents the latest available evidence on disaster risks, such as floods, wildfires, or diseases that are threatening the EU. So drawing on the national risk assessments developed by the different member states and on the Commission's cross-sectoral policy and scientific work. These national risk assessments that you might see here in this chart diagram are primarily an instrument to support national disaster risk management work. However, they are also a valuable source of information for action at the EU level because, for instance, we can guide the process of prioritizing the cohesion policy investment, and among other things, we can indicate the areas that could benefit from greater cooperation, exchanges of experience, or capacity building in order to build up the evidence basis for disaster risk management policies across the whole Europe. So a greater action is needed to build this resilience of critical infrastructure to intensify natural hazards and man-made threats. If we consider that these threats can also affect the society and vital services such as energy networks, water, or even communications and transport networks, we need to make sure that they are resilient to these disasters. So the Commission is working on additional measures on critical infrastructure protection to address the gaps identified in the review of their directives. And they are really putting a greater emphasis on resilience and interdependencies of critical infrastructure, and it will take into account recent developments in the related EU policy areas such as civil protection. So we've all been talking about 5G connectivity, small cell antennas, and all these network equipments. But when things go wrong, how can we protect these networks? This is the main goal of UNICRINF, which stands for Universal Critical Infrastructures. So major catastrophes like the ones showcased before demand efficient coordination and control of resources in order to ensure people's safety. In the era of 5G and IoT, networks and applications play a fundamental role in monitoring and decision-making in all the areas involved. So UNICRIF plans to use the available communications infrastructure to create a global integrated platform that monitors catastrophes, creates an ad hoc on-demand communication infrastructure, and communicate with both emergency teams and the citizens community to advise them on what they should do. So it targets areas involved in a major catastrophe, including the emergency services, the affected people, hospital resources, communication network infrastructure, and more. The fundamental objective is to ensure people's safety during an emergency situation where technology should help and allow information to flow smoothly between all the people involved. So in a nutshell, this project has run for 29 months with around 2.5 million euros of funding, and was coordinated by Nokia, concretely the unit from Spain, with a consortium of 4 entities. The main target of the Celtic Next project is to integrate the best of our technological companies to improve the emergency protocols, including TV emergency support or messaging alarms in small, medium, and large areas. But what is Ubiwhere's use case? So with Unicron, we intend to minimize the negative impact of accidents, for instance, the urban earthquake scenario, ensuring that we have steady minimum telecommunication services so that the emergency protocol can be quickly, effectively, and easily put into practice. Our focus is to target the post-catastrophe remaining infrastructure and develop protocols, interfaces, and other solutions that ensure the automatic recovery of the telecommunication system of a city. So if you have been paying attention to the last sessions, you might have seen my colleague Pedro Diogo talking about the smart lamppost or the street furniture that we enable 5G connectivity using small cell antennas that enable neutral hosting, other concepts that both the other speakers from session 1 have also mentioned, and also Paul Valent. This plug-and-play edge computing solution, so the lamppost, which also allows for computing units to run, lets different service providers to deploy compute, storage, and network resources in a distributed way. So through the marketplace, you'll be able to implement different applications throughout the city. So a particular small cell that will be embedded within the lamppost at the edge of the network is permanently interconnected with a fiber optic cable to the core of the network, as you might have seen in the previous slides. But the lampposts here should also have the capability, at least some of them should have the capability of using satellite to connect to the backhaul with the control of a multi-access edge computing application that's responsible for handling all the communication between these devices on the lamppost, so the IoT sensors, the user equipment that's using the network around, and even in the interconnection between the different small cells, between different lampposts or different street furniture, and the core network services. So what happens if a catastrophe disrupts telecom infrastructure? What happens if this small cell that provides 4G or 5G connectivity loses the network because the optical fiber is disrupted? So essentially, all the hardware equipment under this small cell realm should be equipped with an energy backup system, which shall be enabled in case of power failure. That's the biggest use case or the biggest challenge up front. But our focus is on the multi-access edge computing app that is responsible for analyzing the connectivity parameters and sensors data in order to detect the anomalies in the network, which could cause the service or even connectivity disruptions. So the idea is to foster this analysis and quickly respond. So upon the occurrence of an earthquake, the specific IoT sensors that would be enabled within the lamppost or the street furniture, which are linked to the small cell providing connectivity, are able to detect the shake or the vibration of the ground and report this information to the MEC app, which is also running in the nearby in the edge environment. So these specific sensors, which you can see on the cloud solution on the left, are geotagged. So they are, when they are deployed, we know the location of the different sensors. So we can know whenever this sort of event or catastrophe happens, we know the geographical area and the most affected areas, depending on the distribution and density of these sensors. From the MEC app point of view, by analyzing this information reported by the sensors and the disrupted connection with the backhaul, it becomes essential that it enforces the connectivity to the network core and triggers the creation of an ad hoc network to provide as much connectivity as possible in this scenario, so relying on mesh connectivity. So the first step of this process is to enable the satellite link that provides connectivity to the core. The second step is to create an emergency network, namely the Wi-Fi access point, as a way of providing immediate assistance and to the end users and emergency response teams. To be noted that these emergency networks will have limited connection to the internet, only allowing critical services to be functional, with the goal of providing basic infrastructure in order to facilitate the search and rescue operations. But how does this Mac app do this so efficiently? That's how we created this smart event processor. In order to do this efficiently at the edge of the network, we have created a framework designed to be deployed at the edge with the main goal of providing real-time monitoring of data that comes from IoT devices, such as probes and sensors. And this framework can generate complex events based on the correlation of the data that triggers potential actions to respond and react efficiently. So if we look at it in a high-level logical architecture of the deployment, we deployed the SEP framework on the network edge close to the location where the raw data is generated. So to the devices, to the sources, to the lampposts or other street furniture that is connected to the network. The large amount of raw data that are processed by this SEP module will ultimately generate complex events and transfer them to a third-party control application running in the cloud, the urban platform that you have seen in the previous figures. Since this is a large quantity of raw data that the sensors can generate, so looking at vibration, looking at the ground shaking, and looking at other parameters such as temperature, noise, etc., in comparison with the quantity of generated complex events, we can reduce the amount of communication data that's transmitted from the devices on the ground to the cloud provision servers that will be able to manage the first respondents. So if we look into detail how this works, it basically consists of two modules, the raw data processor at the bottom level and the complex event processor. So the raw data processor is basically sensing data provided by the devices, pre-processing it, filtering, and storing them in a database. Some types of the data are time sensitive, so they come from accelerometers capable of detecting earthquakes, as we've mentioned before, and they are directly sent to the data dispatcher to be immediately handled by the complex event generator. Other types of data, which are more tolerant to delays and do not need immediate response, are processed by the data aggregation submodule and later dispatched when a configurable amount of data or elapsed time is reached, this way reducing the amount of data that goes up and forth and back to the cloud. The complex event generator implements a complex event processing rule engine, which basically receives data from the raw data processor and matching it against the rules that are stored in the database. If the matching is successful, so if we see that, okay, this corresponds to an earthquake, a wildfire, or any other sort of catastrophe, the complex events are inferred and generated to the upper application, in this case, the urban platform in the cloud. So in some cases, the SEP engine also analyzes previously generated complex events history to infer certain events more accurately. So not only relying on the real-time data, but also leveraging on the historical background. And all of this then integrates the urban platform, which aims at solving city challenges through an integrated approach for smart cities. So the urban platform is capable of integrating data from any vendor or vertical from different domains, standardizing the communication protocols and data models, and allowing to correlate the different domains and provide a global overview of a region or city. The SEP model integrates into the urban platform to unlock new use cases, and that allows expanding the current users it already covers. So not only for municipalities or city service providers, but also first respondents and civil authorities. At this stage, the main focus is to integrate this component into the urban platform and leverage the market traction that the urban platform already has within different cities all across Europe to showcase the full system in new market segments, as I mentioned, as first respondents, firefighters, and civil authorities. The idea is to exploit this with a monthly fee, replicating the business model we have with municipalities. So by giving this real-time status of what's happening and being able to aggregate the different events and complex events that happen that not only come from mobile applications or community-based data sources, we can also then have a more efficient response to infrastructure disruptiveness, making sure that we can then find the quickest unit or a team ready to handle this specific event, getting more context on the different causes of that event, and having customizable workflows that dispatch to different units, ensuring that people's safety is ensured at the earliest stage possible. So this is the overview of the Ubiwhere project, getting into a bit more detail on the smart event processor that we have developed, which we aim to help us suiting the future of sustainable and connected communities. So I'm really happy and proud of the results we achieved, and I look forward that you might have any questions or clarifications about any of the developments done with the EU Celtic Next funded project Ubiwhere, and I'm happy to look for new opportunities to evolve the solution, to test out in new scenarios, and look for other collaboration opportunities. Thank you very much for this opportunity.
Here and for your intervention. It's great to see that the impact that 5G can have on the diverse sectors within a city is so relevant as impacting over safety, as you mentioned. I do have a question for you, if you don't mind. At a time in which the pandemic reminds us that disasters and occurrences can happen really easily, does it make sense to have a feature like this? And if so, what paths should cities take to prepare themselves for this?
Absolutely. The pandemic and the health causes are some of the emergencies and catastrophes that the Commission is monitoring. So we were forced to change a lot of habits, and it's efficient that we now look into what we have changed, what was the impact of these changes, what had to change in terms of infrastructure, transportation, and all of the networks that enable a smart city or a community to work and live. And I think that by sharing that experience, so by sharing the different challenges, data used, services that improved or solved a specific challenge, will really foster the next pandemic, will really foster our resilience, our recovery from all of this. So it's not a matter of only preparing with equipment, but also with knowledge. And every city that and region, regardless of their dimension, has faced the similar, or at least the same domain challenges at different scales, and all of them can give something to others to learn. So it's just a matter of engaging those best practices and recent success and stories and lessons learned, that we can evolve and get ready for the next challenges and pandemics and whatever comes.
Okay, thank you. Thank you very much.
Thank you.
So I believe we can all agree that this was a very enriching webinar. We got the chance to touch on several relevant themes of the 5G industry. To make you a quick wrap up, our speakers give us an overview of what is 5G and the real impact it can have on everyone's lives, and led us to discover disruptive solutions that allow its implementation and massification, that allow us to seize the full potential of this new technology. We've also had the opportunity to discover the neutral hosting approach, which is an innovative response for cities to accommodate the 5th generation network and unlock a wide set of opportunities, not only for cities, but for businesses and all the vertical sectors involved, highlighting Ubiwhere's use case for 5G network accommodation on diverse European cities and for its application on sectors like safety. These sessions have shown us that 5G can effectively bring a wide set of benefits which we were not aware so far. It proves that 5G is here to stay, and that cities have much to gain by focusing on studying, researching, and experimenting the challenges and opportunities inherent to this reality. I would like to thank all the speakers for accepting our invitation to join the session today. I would also like to thank my colleagues, Luis, Ricardo, and Pedro, for sharing a piece of their experience on each one of the topics. From our side, we're available to answer any of your questions. You can reach us whenever you wish by email. Everyone who has signed up for the event will receive a certificate of participation at the end. But if you haven't signed up and still wish to obtain the certificate, you can send us an email to hello@ubiwhere.com and we will promptly send it out to you. So I give this session closed and I wish you a very nice day.